So, as I said, we have 3 types of problems here. On the test, we will give you the equation. You will not have to figure out which type of equation you have to use, but of course you do have to understand the meanings of the variables. Now, when you're going through the word problem, the context itself pretty much gives away which type of equation we're going to use. Once you've seen all 3, this is going to be much easier. Number 1, Carl plans to invest $500 at 8.25% interest compounded continuously. That's your dead giveaway as to what this is. How long will it take for his money to triple? So one of the 3 problem types is the continuously compounded interest. We don't go that far into interest in pre-cal, but if you study the topic at all or taken another class with it, you'll know that interest has a lot to it. There are different types of interest. They have to tell you what kind of interest, so they must use those words compounded continuously for you to know that that's what you need to do. So we're going to use that middle equation. This is A equals PE to the RT power, often referred to as the PERT formula. How I go about these problems is actually how you would approach it in a science class, such as chemistry or physics. A lot of the math in those classes you may or may not know are problems like this, where here's a formula, you have to fill in what you know and solve for what you're missing. So I like to set up all my variables on the left side and fill in what I know, just to keep my work organized. So I have capital A, P, E is not going to be a variable, it's a number, R, and T. From the problem, we'll be able to fill in 3 of the 4, the 4th one being what we're solving for. Carl plans to invest $500 at 8.25% interest. So he plans to invest $500. That's going to be his starting amount. If you look at the descriptions above here, you'll see that P is the initial investment. It's how much money we start with in the account. So P is going to be that 500. $8.25%, that's the annual interest rate. So R. Hopefully you are aware that we never plug a percentage directly into the equation. What do we do instead? Yes, what is this decimal?
0.0825.
Yes. Move the decimal back 2 places to the left. That is the number we'll be plugging in. Second sentence, how long will it take for his money to triple? So that how long, that's the question that we're answering, so that's T. T is what we're solving for. So T is the unknown. We have to figure out what A is. We have to know what A is to start the problem. That information comes from the very last few words. Money to triple. He wants triple what he started with. So what is A? 1,500. So if you didn't follow, if we're tripling the initial amount, 500 times 3, 1,500 is what he wants to end up with. From here, let's plug it all in and solve for T. We have 1,500 equals 500 E to the 0.0825 T. From here, This is an exponential equation. Before you can switch the form, you must get the exponential part by itself. When we switch the forms, we need just e to be the base, not 500e. We need to get rid of the 500. So in this case, we're going to divide off the 500 before we switch the forms. So this becomes 3 equals e to the 0.0825t. At this point, we can now switch the forms. Base stays base, the other two switcheroo. E, remember, uses the natural log ln, but if you prefer log base e, that's fine. That's what I'll be writing. Log base e, and then we're going to switch the other two values of 3. And then on the left side, we'll have 0.0825t. You are allowed to go ahead and put the right side into your calculator to go ahead and get a decimal, but I personally like to wait until the end to get my decimals just so it doesn't affect any later rounding, but that's just me. So to finish solving, we would of course divide both sides by this decimal, and we would have t equals 0.0825. Oh, I did that wrong, didn't I? Yeah, I did. Okay, hold up. Nothing a little wide out can't fix. It'll come out. There we go. Okay, let me try that again. Log base e of 3 on top divided by the decimal, 0.0825. And then we'll need our calculator to finish that off. Math alpha math to get that log onto the top of the fraction. Reminder to get that just e as our base. That's above the division sign here. Don't know if it's going to focus. Let me try it one more time. Nope, it's not going to work. But above the division sign, you should be able to see on your own calculator, you've got the e. So log base e of 3 over 0.0825. Up until this point, and I'll have to check the test, but I'm pretty sure the standard has been and will be 3 decimal places. So that's how many we're going to go out today. 13.317 years. And there you have it. Any questions over number 1? The setup, solving, any of it? Number 2. A certain strain of bacteria grows from 40 to 326 in 120 minutes. Find K for the growth formula. So there's 2 hints as far as which formula we use. They are the words grows and growth formula. That refers to the very first formula. The third formula can refer to an increase and decrease as well, but the third formula really deals with property, so houses, cars, boats, even laptops. Whereas growth and decay really refers to populations of things. It can be bacteria, it can be animals, it can be human population, things like that. So more likely than not, you're going to be using growth and decay formula. So we have y equals NE to the KT. My variables are y, n, k, and t. We are directly told that we're finding k, so we know right off the bat that's the unknown. And we're told that the bacteria grows from 40 to 326. If we go back up to the explanations for the different variables, n is the initial amount, so what you start with, and y is the final amount, so you can think of n as the before and y as the after. So we start with 40, n equals 40, and we end with 326. And t is 120. In this formula, t can represent anything. It could be minutes, seconds, years, months, weeks. It really doesn't matter. So it just kind of is what it is for the given equation. All right, let's plug this stuff in. We have 326 equals 40 e to the k times 120. The solving is going to look identical to number 1. Once again, we need to get the exponential part by itself first, so we need to get rid of the 40. Once again, that means we will divide both sides by 40. 326 divided by 40 is actually nice. It's 8.15 equals e to the, I'm going to flip these around, 120k. And then we switch the form. Base stays base, the other two switcheroo. This becomes log base e on the right side, and then we'll flip the values. Log base e of 8.15 is equal to 120k. And then just like last time, to get the k, we're going to divide both sides by 120. K equals log base e of 8.15 divided by 120. Calculator to get our answer. Rounding that to 3 decimal places, we have 0.017. And k is just a constant. It never has a label. So it's just going to be the number this time. Questions over number 2. Number 3, the final type. A $40,000 car depreciates at a constant rate of 12% per year. In how many years will the car be worth $12,000? So the dead giveaway here is the word depreciates. When we're talking again about the value of a piece of property, typically it will either appreciate in value or depreciate in value. Unfortunately, a lot of things like houses, or not houses, houses can go up or down, it depends. But cars, boats, anything like that, those will typically depreciate in value. So this is not shocking here. So we're going to use the third formula. We have V sub n equals P times 1 plus R to the nth power. Our variables are V sub n, P, R, and N. So first we're going to start with the $40,000 car. That is the initial value. That's how much it was before. So P is the $40,000. And it depreciates at a constant rate of 12% per year. So the rate is 12%. Since this is a depreciation problem, I have to include something else here with that percentage. It's going to be negative. It's going down in value, so we actually have to represent that in the rate. So it's actually a negative 12%. So we'll rewrite this as negative 0.12. I'll add a little note there for anyone who needs it. Use a negative for depreciation. So that is one small detail to keep your eye out for. Second sentence, in how many years, so that's the question. This time, it's not T, it's actually N. N just stands for a number of years, so that's the unknown. In how many years will the car be worth $12,000? That's the after or final amount. So V sub N is 12,000. We have all our values, let's plug them in. We have 12,000 equals 40,000 times 1. Since it's a negative rate, I'm not going to put plus minus. I'm just going to write minus 0.12 to the nth power. Yes?
Why do you put n on the left side?
Why do I put n on the outside?
Why did you put n on the left side?
Why didn't I put n on the left side?
Yeah.
This n? That's V sub n. This is one variable. That's different from just n. Yeah. First thing I'm going to do here is just condense the two numbers in the parenthesis. I'll rewrite that. 12,000 equals 40,000 times 0.88 to the nth power. From here, the solving, again, is going to be identical to the first two. Divide by 40,000 on both sides. $12,000 over 40,000, that is just 0.3. No rounding there. Equals 0.88 to the nth power. You can drop the parentheses if you like. From here, we can switch this around. Base stays base, the other two switcheroo. This is now log base 0.88 of 0.3 equal to n. We'll round that off to 3 decimal places. Three decimal places puts us at 9.418. And if it has a label, make sure you include that. So it's in years. That is all. Any questions over the third problem or any of the others?